Hello, hello. This is David McCormick. I'm coming to you pre-recorded from Grand Rapids, Michigan. So this is my Venture Labs presentation. The technology I have selected is called nanostaking, and this is a technology that I work with at my job, and so I've been involved in some of the development, and so I do have a little bit of passion about this, and I thought it would be a good topic to choose because I can speak to some of the business side of it a little bit, and also kind of imagine what some of the answers are that I don't know from my work experience, but learning through research. So let's get into it. A quick overview: plastics joining is when two pieces of plastic are joined together. Oftentimes there's a boss that goes through a mating hole, and then that boss is heated and then formed into a cap that forms a joint. And this is very common for automotive parts that, if it's not feasible that it's all one piece for an injection mold, then we join two parts together this way. Nanostaking is a new method of heating that requires much less energy than others, and it can get in. It's a much smaller module. It can stake very small parts. Right now we use it a lot for making headlight assemblies. That's what I'm working on currently because they have very small bosses, and the other alternatives out there. We sell a very typical one called we use infrared light to do this, and it has a lot of advantages and it has a few drawbacks. Other companies just do straight up heat stakes where they just have a hot punch that gets really hot and just kind of forms it. That's a very messy process. Doesn't leave nice bosses. And then there's ultrasonics that work for a lot of applications, but not when you need a clean stake, and it also really disrupts it can hurt the electronics. So this is kind of what I've already just talked about here. Nanostaking uses a very small amount of electricity. There's other companies doing a similar method to this with a tiny heater right near the tip, but they use a lot of electricity. They have to have huge wires coming to their modules, and then large transformers, and they haven't refined it the same way that we have refined the nanostake. This uses a tiny amount of electricity. Just heats up the heater just when the staking happens, and then it cools down right away. So it's a very useful tool for integrators. Here's my vision statement. Creating nanostake technology is a way for us to add value to our customers by opening up new opportunities for plastic staking. Nanostaking will be a continually developing process that is responsive to the marketplace and always in search of new applications for its use. No other staking solution will offer such clean and strong stakes in a wide variety of plastic products as Nanostake will. We know that by offering an efficient, low-cost alternative to the companies out there, we will form long-term relationships with our customers. So, the stakeholders involved in this, goes like this. There's a product owner. He drives the whole program and directs the team in making key decisions to achieve the outcomes that we need. The chief technology engineer has the most knowledge of the product. This is probably the person who developed the technology and is kind of the go-to source. And so then we need to involve also the sales lead in this, because as we form our market plan and look at what does the end product need to look like and who are we serving, the sales lead is really critical in providing a lot of that information, getting info from our existing customers so that we can make sure we're meeting those needs. And then there's a development team that has controls engineers, mechanical engineers. They're cross-functional. They should be able to execute all the needs of the project within the team for the most part. There might be some people that have to pull in from outside, but for the most part, we're self-sufficient. And then there's investors, so providing a funding source to get started and to get this out into the marketplace. It's a very important role. This is the opportunity diagram. I've rated it pretty high, 95%, 75% for resources, context at 80%, teams at 95%. I wasn't quite sure exactly how to get good strong numbers on this, so kind of trying to just, it seems like a kind of a subjective guess to me. So if there's a better way to rate this, I would like to learn about that. So the value proposition is, we're answering the question, which of our customers' needs are we meeting, and what are the key product features that meet those needs? So our customers are automotive suppliers, typically, and they need robust, clean, efficient staking. That, like I pointed out, the other staking options out there, they will often fail at one of these aspects here: robust, clean, and efficient. So we like to accomplish all of those three very well, and we need to provide a staking technology that creates fast and strong welds with a minimal amount of energy and without those undesirable side effects. And then, of course, the goal is to do this in an affordable way, so that this can be widely implemented and be an attractive alternative to the others. Because if it costs too much, then they'll say, well, that's real nice, but we're not spending money on it. And here is a business model canvas that I've created. So the value proposition boiled down is that we offer customers the flexibility to stake smaller and more delicate plastic parts at a lower cost than most comparable technologies. The customer relations, we get customers by offering staking solution that is unique, and we keep them by providing a robust platform that adds value to their operation. We're going to keep customers because we're going to service them and provide value to them. The key activities we do is provide the design and manufacturing expertise to efficiently create these products. We reach our customers through channels. The channels that we use we have existing relationships with customers because we've been in this business already for a couple decades. So we've got channels already in place. Key partners could possibly be partnering with software developers, material science consultation, market researchers, if we need contract labor to get products made and out the door on time. Another one I didn't write in here is we could do consulting with other like design stuff. We could use an industrial designer for some of the design work. We could consult with I don't know, any number of other consultants. One thing I'm thinking of is we brought in a consultant to come give us a couple days workshop on Scrum design process. And that was directly applied to how we were doing our design process for the NanoStake. So that was a partnership, I think. Our customer segments, I mentioned tier 2 automotive suppliers. These are the ones that buy the machines and the modules from us and create the components that they then deliver to the tier 1, Ford, GM, etc. And a key resource that I've listed is that we use a rare metal alloy in this technology, so its pricing and its availability is a very important thing for us to have figured out and locked down. Okay, so that is my presentation for NanoStake. Hope you enjoyed it. Please let me know if there's anything I can improve or clarify and how to go forward from here. Okay, thank you very much. Have a nice day.